Hi, in this video we're going to talk about the different types of symbols that are used for both set notation and interval notation. We will use set notation and interval notation to state characteristics of functions like domain and range, intervals of increase and decrease, and positive and negative intervals. So for set notation, here's a list of different symbols that you might see used for set notation. This first set of symbols is what we call set brackets. And these set brackets are used to enclose anything that we're talking about as part of a set in mathematics. So sometimes you might see this used to indicate a set of individual numbers, like the set of numbers 1, 2, 3, 4. And sometimes you might use this to see some other notation used inside the set brackets to indicate a more continuous set of numbers, or for example, the set of all real numbers. We can put some notation inside those set brackets to indicate which set of values we're talking about. But whatever is enclosed in those set brackets, it's known as a set of something. This symbol here, it looks kind of like a fancy E. It is known as element of, or you can think of this as belongs to. This symbol here looks like a vertical line. It represents such that. And so this vertical line here is used when we have a set of conditions that need to be that need to be satisfied for a value to be in our set that we're defining. So that could be, for example, if we say that something is it belongs to the set of all real numbers, but we have added conditions that the value must be greater than 3, then we would use this notation to indicate something like all real numbers, and then that vertical line such that, and then we follow that by the conditions that we want to include. At the bottom here is some different symbols that are used to represent different sets of numbers in math. So this fancy R represents the set of real numbers. That's used for when we're talking about continuous sets of values. This fancy N represents the set of natural numbers. And natural numbers would be the set of values starting at 1 and increasing. So that's our regular counting numbers. And Z represents the set of integers. And so that would be positive, including positive and negative integers. And then we have our greater than and less than symbols, as well as not equal to, that you'll see show up in set notation. Okay, and we'll also go through the symbols used for interval notation, and then we'll see some examples where all of these different symbols are used. Let's start with this. This E shows up again. It still means element of or belongs to. This is a symbol that's used in both interval notation and set notation. So we can say something like X is an element of the set of real numbers, or in other words, X belongs to or is a real number. We've got our infinity symbols here. So infinity, and we can put a negative sign in front of it to indicate negative infinity. This U is the union symbol. And it's used to link several different intervals together. So you can think of this union symbol as replacing the word and. So if we want to say this interval and this interval, then we would include a union symbol to indicate that. These round brackets are what we call open brackets. And these square brackets are called closed brackets. And these brackets are used to indicate whether values are included or excluded as part of your interval. So these are kind of another way of indicating greater than or less than, or versus greater than or equal to and less than or equal to. So you'll see some examples of how that works, but open brackets indicate that endpoints are not included. So the endpoints of the interval are not included in your interval. And closed brackets indicate that endpoints of the interval are included. Okay, so let's see one quick example in this video, and then we're going to take a look at a separate video for a more in-depth example. So here's a function where the domain happens to be all real numbers except for 0. In set notation, we start by opening up a set notation bracket. So again, that's going to indicate that everything that comes inside those set brackets is a set of values that we're trying to state a set of values that fit for our domain. So we want to somehow use that notation to indicate that this set of values is all real numbers except for 0. So we're going to start with x, which is our independent variable, and that's what we're stating values of x that work for our domain. So we say x is an element of the set of real numbers, or in other words, x is a real number. But we don't want to include 0. So we have extra conditions other than x is a real number. So we use the such that symbol. And then what follows is our extra conditions. So x is a real number such that x cannot be 0. That's our only condition, just accept 0. So that's the only condition that we need to put following the such that symbol. So then we can close our set notation brackets. So this is read as x is an element of the set of real numbers, or x is a real number, such that x cannot be 0. X can be any other real number, just not 0. In interval notation, we still start out with x is an element of, okay, so this is x belongs to, and we're going to list the intervals that x could belong to, but you're not going to use the set notation brackets in interval notation. So x belongs to, and we're going to state the intervals starting from left and going to the right on our graph that x belongs to. So if we start from the left, x could be any real number, any value from -infinity up to 0. So our first interval is going to say from -infinity, comma, up to 0. And we're going to surround this interval by brackets. With an infinity symbol or a negative infinity symbol, we're always going to use the open bracket. So the open bracket is always going to be adjacent to the infinity symbols. And that's because infinity isn't a particular value. It is more of a concept or an idea. And so because of that, we're not really including the value of infinity in our statement here. And so we use an open bracket always for infinity symbols. And then the bracket that goes on the other side here, we want to determine, do we include 0 as part of our domain or not? And in this case, we do not want to include 0 as part of our domain. And so for that reason, we use an open bracket. If 0 was included as part of our domain, then we would use a closed bracket. Now, this only covers the first half of our graph, the left side of our graph. We still need to include the domain for the right half. So we need to list another interval. So we use the union symbol to connect the two. And then we state the next set of values that would work for our domain. So starting from 0, any x value from 0 to infinity is part of our domain. So we say from 0 to infinity, so 0, comma, infinity. Once again, we use an open bracket adjacent to the infinity, always. And the 0, same as before, we do not want to include the 0, so we use an open bracket adjacent to the 0. So this is read as x can be any value from negative infinity to 0 and from 0 to infinity, but not including the 0 because of those open brackets.